When factoring an expression, the first thing you want to look for is a GCF, or greatest common factor. So what you do is you look at all the terms of your expression and see if there are any common factors. It could be a number, a variable, or both. In this case, the common factor between the 3x and the 12 is a 3. So what you do is you write this greatest common factor, and then you multiply it by what would be remaining if we were to multiply this out and get back to the original. So in this case, in order to get back to 3x plus 12, inside the parentheses would be an x plus 4. Because again, if we were to multiply this out, we would get 3x plus 12. So in red would be the factored form of the original expression. Right, another example would be this. So 4x squared plus 2x, we have these two terms. So I look at those and think what can be divided out of each, or in other words, what is the greatest common factor. So each of these can divide by 2, and each also have an x. So 2x would be my greatest common factor. And then what would be multiplied to get back to the original would be 2x plus 1. And again, we can check it by multiplying it back out, and we see we get 4x squared plus 2x. So we know that we have correctly factored that. In this case, you see that we had a number and a variable, both part of the greatest common factor. Okay, here's a trinomial, and we do the same thing. Here we have 3 terms, and looking at those 3 numbers, the greatest common factor that goes into all of those is 6. So I can just take a 6 out, and then what would be left over in the parentheses would have to be a 2x squared plus 7x minus 3. So here GCF was only a 6 because each term didn't have an x, only the number was the common factor. Okay, let's try one last one here. Here I have 2 terms. Let's see, between the 8 and the 12, in common there's a 4. And the first term has 4 x's, the second term has 3 x's. So they both have at least 3. So I can factor out 4x cubed, which will leave us with a 2x plus 3 left inside. So that is now factored. Okay, well this next one, why don't you pause this and try it on your own. And here's the answer.